Guys, this is Shobit, and today I'm going to show you the comparative analysis of machine learning algorithms on a certain type of data set. So the data set I have used is related to the direct marketing campaigns of a banking institution, which were mainly based on phone calls. So this data set is an example of a classification problem in which our goal is to predict whether or not the client will subscribe to a term deposit. So that column in our data set will be a y variable, and there will be various input attributes. And I've obtained this data set from the ICS website. You can check it out if you want. Okay, so this is what the CSV file looks like. As you can see, it is a lot, and there are around 45,000 rows. So they are separated by a semicolon. So the first step would be to make this data ready for the model to understand and then develop machine learning algorithms accordingly from there. So I'll take you straight to the code, and here it is. I've done it in Google Colab. So starting off, I've imported pandas and NumPy, and I've loaded the dataset onto Google Colab by using this code. And the file has been uploaded, and this is just to make sure that it has been. So this is the read command, as you can see. This is what our dataset looks like, the first 5 rows. Okay, so I've used ILog to separate the data set. So basically the input attributes, which are known as the x variables, are all on one side, and the y variable, which is dependent, is on another side. So that will be a single column, the one we have to predict, and the others, which are independent, the input attributes, are separated into another set. So that's what this does into x and y variables. So that's done. And here we go to sklearn preprocessing, and we import label encoder and one hot encoder from that. So what the label encoder does is it converts any kind of categorical text data into the numerical data so that our model can understand that and process accordingly. So text data as in jobs, like you have management, technician, entrepreneurs, blue collar. So it'll assign numbers to this, for example, 1, 2, 3, and 4, because we can't have text data in machine learning algorithms to predict. Okay, so when that's done, we use one hot encoding because, for example, if we need to analyze all these columns, the machine learning algorithm will assign some sort of relationship to these values. For example, if management is 0, technician is 1, 2, 3, and 4, so on, it will say that this is greater than this or this is less than this, and form patterns which we don't need because every value is unique in its own term. There aren't any relationships between them. So that's where one hot encoding comes in. And what one hot encoding does is it takes the column, which has obviously, which is categorical data, and which has been label encoded, and then it splits the column into multiple columns. Numbers will be replaced by ones and zeros depending on which column has what value. So that's the part of this part of the code. That's the job. And next comes standard scalar. So what this does is it transforms our data such that its distribution will have a mean value of 0 and a standard deviation on 1. Basically, it normalizes our features. Since all of, for example, this balance is in a particular range and a day is in a particular range, durations. So what this does is they will now all have a common scale. So they will have a common scale while building the machine learning model. This is what that does. And this is just, I've split my data set into three parts, two parts, the training and the testing part. So I've manually done this. As you can see, I've taken the test size as 25. So 25% of the whole data set will be gone into testing. And yeah, so that's this part of the code. The 75% will be used for training purposes. Right, so that's all the pre-processing done. And now we move on to the machine learning models itself. So first up is logistic regression. And from sklearn.linear model, we import logistic regression. Pretty simple. And what this does is basically it's a predictive analysis. It explains the relationship between one dependent variable and one or more independent variables. So this is how it works. We transform and fit it to our data and impose a penalty accordingly. Right, so this is the prediction, and I've printed all the important scores that you need to see. For example, the accuracy, the precision score, recall score, and F1 score, as you can see here. So my accuracy is pretty good here. Precision score, recall score, and F1 score, you can see that accordingly. And that's one linear, oh, I'm sorry. That's one linear model done. And I'm sorry, that's one machine learning model done. And we move on to classification and regression trees. So this is basically a decision tree classifier. What this does is it's basically like a flowchart like tree structure. It builds classification models in the form of that particular structure. So this will break down the data set into smaller and smaller subsets, while at the same time an associated decision tree is incrementally developed. So this is the accuracy for that and the precision score and all the other scores accordingly. That's another one done. And we move on to Perceptron. So Perceptron is basically like a single layer neural network. It is a layer classifier which can decide whether or not an input belongs in a specific class. So this is it. We fit it. And as you can see, this is the accuracy. So that's all there is in the code for the perceptron, and so same is the case for random forests. So random forests, they consist of a large number of decision trees. Each individual tree spits a class prediction, and the class with the most votes becomes our model's prediction. So here it is. This is the code for that. It's basically for everything you import it, it's already done. And everything's mostly predefined and it does the job on its own. So this is the accuracy for that, precision score, recall score, reference score. And moving on to the last algorithm, those are neural networks. So yeah, basically, these are a series of algorithm which recognizes underlying relationships in a set of data. Like it's composed of nodes in layers. So we have an input layer, we can have several hidden layers, and we have the output layer. So it works like our brain does. So each information which is processed by a node and the output of that node is taken in by another node accordingly, and depending on that output of the previous node, the output of this node goes into another one and eventually reaching an end output. So basically it's all importing the libraries, and I haven't manually defined anything except for the layers, 128 layers for the first and second one, and then the final one will be only two, the output layer, because I only have to predict yes or no. So the activation function for those ones will be ReLU, and the other one will be of softmax. So as you can see, I've run the epochs, and predicting the accuracy and precision scores is this, right? So I've ran this for several splits. I've ran it, for example, in this case, I've showed you for 25%. And I've ran it on several other splits like 60-40, 80-20, 50-50. And in all of the cases, I noticed one thing, that logistic regression was showing the most accuracy. It was the highest amongst all the models we've seen just now. And the reason for that is it assumed that there is one smooth decision boundary by making certain assumptions. So it worked well in our case because there was a decision boundary and it wasn't necessarily parallel to the axis. Since this has a low variance, it will be less prone to underfit, thereby giving more accurate results. So in this data set as well, the signal to noise ratio was quite low, which favored regression as well, hence the highest accuracy. So that's all I have to say. This was the analysis of different machine learning models on a data set. Hope you understood, and thanks for watching.